Hello. Okay. Yes, will you be able to hear me?
Yes, sir. Yes, sir.
Okay, in the morning session, I discussed about the frame structure. Okay, FDD and TDD frame structure. So I stopped at this physical transmission, right? As I said, the user equipment will determine the channel quality indicator index. Okay, so that will provide the highest throughput while maintaining at most 10% block error rate. So these are the different CQI index. Okay, that is from 0 to 15. So totally there are 16 channel quality indicator indexes there. Okay, and different types of modulation techniques are opted here. One is QPSK, next one is 16 QAM, and another one is 64 QAM. So, and with different code rates. Okay. So with that, so this is the efficiency. Okay, with different CQI and different modulation technique with different coding rate, you'll be able to achieve so much of efficiency. Okay, so with a channel quality indicator index of 15 with 64 QAM and coding rate is of 948, it is possible to achieve an efficiency, means spectrum efficiency of 5.5547 bits per second. Okay. Okay.
Sir, full screen, sir.
Full screen. Full screen. Think how to. Okay. Yeah. Is it of video? Okay. So next one is the synchronization signals. Hello.
Yes, sir.
So next topic is a synchronization signal. These synchronization signals are used in the downlink, that is from base station, that is E node B, to the user equipment. Okay, these downlink synchronization signals are transmitted to facilitate the cell search procedure. So I'll come back to that. What is the cell search procedure and all? So during this process, the time and frequency synchronization between the user equipment and the E node B is achieved. Okay. So the purpose of synchronization signals in the downlink is what? To facilitate the cell search procedure. During this process, what I said, the time and frequency synchronization between the user equipment and the ENB is achieved. Okay, and the cell ID is also obtained. Okay, that is what is written here. Okay, both the FDD and TDD versions of LTE broadcast the synchronization signals in the downlink direction. Okay, so those synchronization signals are primary synchronization signal, and second one is secondary synchronization signal. So as I said, the synchronization signals are broadcast within every 10 millisecond radio frame. Okay, so as I said in the morning, one radio frame is of duration 10 milliseconds. Okay, so the user equipment uses the synchronization signals to achieve radio frame, subframe, slot and symbol synchronization in the time domain. Okay, and it also used to identify the center of the channel bandwidth in the frequency domain. And it is also used to deduce the physical layer cell identity. Okay. So the detecting the synchronization signals is a prerequisite, okay, to measure the cell specific reference signals and decoding the MIB, that is a master information block on the physical broadcast channel. So in a nutshell, what I wanted to say is the purpose of synchronization signals transmission in the downlink direction, that is from ENB to the UE, is to facilitate the cell search procedure. In this process, what happens? The time and frequency synchronization between the user equipment and the ENB will be achieved, and it is also possible to determine the cell ID. Okay. So as I said, there are two different types of synchronization signals. One is primary synchronization signal, and second one is secondary synchronization signal. Right. So as I said, these synchronization signals are transmitted or broadcast within every 10 millisecond radio frame. Okay. So primary synchronization signal. Okay, the PSS is broadcast twice during every radio frame, right? And both the transmissions are identical. Means in every radio frame it is transmitted twice in a frame. So and they are identical. Means in case of FDD, means again here two types, no, in the frame structure. One is FDD and TDD. So in case of FDD, what happens is the PSS, that is primary synchronization signal, is broadcast using the central 62 subcarriers. So with the normal CP, I said there will be 84 resource elements, right? Yes or no? So with one PRB, there will be 12 subcarriers. Okay. So with a bandwidth of 1.4 gigahertz. So here I told central 62 subcarriers. So there will be 6 resource blocks, 6 PRBs. Okay, so in this the PSS is broadcast in the time slot 0 and 10. That is last symbol of time slot 0 and 10. So I will come back to that figure. So with that figure, I think this will be very clear. So in case of TDD, the PSS is broadcast using the central 62 subcarriers belonging to the third symbol of time slot 2, that is in case of subframe 1, and third symbol of time slot 12, that is in case of subframe 6. So subframe 1 is always a special subframe. So the PSS is sent as part of the downlink pilot time slot, that is in case of TDD. Okay, subframe 6 may or may not be the special subframe. So depending upon this uplink downlink subframe configuration, it is a special subframe for configuration 0, 1, 2, and 6. Otherwise, it is a normal downlink subframe. So this primary synchronization signal is used to achieve subframe, slot, and symbol synchronization in the time domain. Okay, it identifies the center of the channel bandwidth in the frequency domain. And it also deduces a pointer towards one of 3 physical layer cell identities. Okay, this means physical layer cell IDs are organized into 168 groups, okay, of 3. So the primary synchronization signal will identify of the PCI within the group, but it does not identify the group itself. Okay. So PSS cannot be used to achieve radio frame synchronization because both transmissions within the radio frame are identical and equally spaced in time. Hence, PSS cannot be used for achieving the radio frame synchronization. Okay. SSS is means secondary synchronization signal is used for that, for radio frame synchronization. I will come to this physical layer cell ID, what it is. So the physical cell, this is a formula used to find the physical layer cell ID. So physical cell layer cell ID, which is equal to 3 times cell ID of type 1 plus cell ID of type 2. Okay, cell ID of type 1 is of 168 groups. Okay, so we have totally 504 unique physical layer cell IDs. Okay, 504 unique physical layer cell IDs. In that, the first one, N1 of ID, belongs to 168 groups. Okay, and the second one has 3 types, 0, 1, and 2. I will explain how to calculate the physical cell ID and all in the subsequent slides. Okay, just let me tell about the secondary synchronization signal. So secondary synchronization signal will be broadcast twice within every radio frame, but here the 2 transmissions of this secondary synchronization signals are different. But in case of PSS is same. In every frame twice it is transmitted in PSS, but at the same symbol in the same slot. But here the secondary synchronization signal, 2 transmissions are different. Okay, so the user equipment will be able to detect which is the first SS and which one is the second one. Okay, so in case of FDD, the secondary synchronization signal is broadcast using the carriers second to last symbol time slot 0 and 10. Okay, what I said, the secondary synchronization signal is broadcast twice within every radio frame. Here, the 2 transmissions of the SS are different, so that the user equipment will be able to detect which one is the first one and which one is the second one. So as I said, in case of FDD, the secondary synchronization signal is broadcast in the second to the last symbol of time slot 0 and 10. Okay. So in case of TDD, the SSS, that is secondary synchronous signal, is broadcast using the last symbol of time slot 1 and the last symbol of time slot 11. Okay. So this secondary synchronization signal is used to achieve radio frame synchronization. Okay. So radio frame synchronization is achieved using secondary synchronization signal only, not by using primary synchronization signal. I will share one more, this one. Yeah. So you will understand very clearly here. Yeah, with this, with respect to this diagram. I hope, is it visible? Hello?
Yes, sir.
Yeah. What I was telling about this
Yes, sir.
secondary synchronization signal, no? I think now
Yes, sir.
with this
It is
diagram.
visible.
Pardon? Yeah, timing of the synchronous signal. I think this will give you a better picture than just saying in words, I feel. Right? What I said, 10 millisecond is one radio frame. In that, there are 10 subframes, right? 0 to 9. So in that, I said the PSS, that is primary synchronization signal, will be sent in the time slot 0, right? In the time slot 0 of last symbol, that is symbol 7. 0 to 6, it is symbol 7. And as well as in the symbol 10, right? That is the last symbol. In the time slot 10, last symbol. In the time slot 0, last symbol. That is the PSS. And secondary synchronization signal is last but one in the time slot 0 and as well as time slot 10. I hope it is clear. Hello.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
So please note down this picture
Yes,
will
sir,
give
it is clear.
Right.
Yes, sir.
Because what I have understood just reading means with theoretical information, you will not get this visualization. At least with this clarity, I hope now it is clear, I feel. Okay. So this is for FDD. In the same way, there is for TDD also. Okay. So this is for TDD. So in TDD, what I said, the secondary synchronization signal will not be same, right? In one time slot, it is different. Means with that, a user equipment will be able to detect which one is the first and which one is the second. See what you find here is, see in case of TDD, there is a special subframe, right? So in the time slot, this one, see, sixth symbol means the seventh symbol is SS, right? And here say uplink subframes 2, 3, 4, 7, 8, and 9. And here in that the special subframes are 1 and 6. Okay, in 1 and 6.
Sir, I'm not able to see the PPT, sir.
Not
It
able
is stuck, sir.
Huh?
No, sir. It is. Yes, sir. It is
Yes.
stuck in this volume
It's
E
stuck, sir.
LTE workshop material. Folder it is stuck there, sir.
But just now they said it was clear. The frame that is this one was
Yes.
clear,
Last PPT was visible, sir. This one is
Ah.
not visible, sir.
not visible.
It is stuck in one folder, sir. Volume E LTE workshop material.
Okay. Hello.
Yes, sir.
Yes, sir. It's still not visible, sir.
Not visible.
Yes, sir.
Not visible, sir.
The folder is coming, sir.
Folder is is asking for upgradation.
Time is limited, sir. We
Yeah, time
won't
is
have much.
limited. It is something is happening. It is asking for upgrade. Okay, don't cut your meeting short. Get more done. Upgrade for some $15, something like that. Don't know why it is coming like that.
Start a new meeting, sir.
Again, I have to create a new ID, no? Or no, still time is there, but why it is happening like this? 40 minutes, no?
45 minutes, yes, sir.
45 minutes. Yeah, it is not opening that folder. Pause sharing. I will again do once again. I will log out and log in. Share. Yeah, I think. I hope now is visible.
No, sir.
Huh?
No,
No,
No, sir.
sir.
It is not coming, eh?
No, sir.
Resume share. Now also?
No, sir.
no, sir. Sir, I think you have to share screen, sir, and select PPT,
Yeah, share screen only. And there only.
and then select the PPT open, sir.
Share. Not coming? Hello?
No, sir, it's not.
No, sir.
Is the PPT open in your laptop, sir?
It is open. It is open in my laptop.
No, sir, you're not visible for us, sir.
Not
Here we are
visible.
not
Then
visible.
try to open it through share screen, sir, by selecting your PPT.
Okay. So this is coming.
Yes, sir, it came now, sir.
Now it came, sir.
Yes, sir, it came now.
No, fine. Here I have not copied the diagram. Written only words. Okay. Oh. Participants mute all. Okay. The participants unmute themselves. No. Okay. Let me do one thing. I will come back to this. I think with diagram only it is better to understand. Okay. I will pick up some more this one. I think this is all I have thought, right? Yeah. Let me discuss in brief about this physical channels. Okay. So as I said, there are three different types of channels in LTE. One is logical channel, second one is transport channel, and third one is the physical channel. So in the physical, hello, in the physical, the LTE uplink physical channels. Okay. So first one is the physical radio access channel, that is PRACH. So uplink is from user equipment to the ENB, right? So it carries means this PRACH, physical radio access channel, carries the random access preamble. Okay, this random access preambles are generated from Z of 2 sequence. Okay, with they are able to make something. When I muted, disable notation. Okay. Yeah, I understand you people are playing it. Some are doing something on slide. So even okay. As I said, in case of LTE uplink physical channel, first one is our physical radio access channel. Okay, as I said, it carries random access preamble, and this random access preambles are generated from the Z of 2 sequences. Why Z of 2 sequences are chosen is because it has a constant amplitude and with a zero autocorrelation function property. Hence, Z of 2 sequences are used for generating the random access preambles. Okay, and second one is the physical uplink shared channel. Okay, this carries the uplink shared channel. On ending of this meeting will end in 10 minutes. Okay. Oh, wait. No, it is asking for buying. No. Hello. ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿದ್ನ ಬೇರೆ ಹುಡುಗರು ಅನ್ಮ್ಯೂಟ್ ಆಲ್.
I didn't hear it.
Yeah.
ಏನ್ ಮಾಡಿದ್ವಿ
Go Corona.